Hello. What we're looking at today is we're going on to our next topic of interpreting graphs. Now, if there's one thing that general mathematics loves, it's graphs. There are graphs everywhere. And the expectation is that you know your way around one. And so what I want to look at today, rather than just going through problems, is I want to look at some of the general, the types of graphs we have to deal with, and also how do we know whether graphs are the important information that are in graphs. It's amazing to me how many people look at a graph, see a bunch of pictures, and don't actually read or understand what's behind it. So the first thing, what are the different types of graphs we're going to be dealing with? Primarily, here we see column graphs, line graphs, sector graphs or pie charts, and divided bar graphs. Now, if we have a look, just a bit of an example of these. So a column graph is this one here that we're seeing. Everything, a whole bunch of columns going up. There's information, a title at the top. There's usually time or something on the x-axis and something on the y-axis. If we see here, pie charts, on the other hand, are charts that display all the information as a percentage of a circle. So the largest chunk, and they're very easy to visualize, the largest chunk is the largest percentage. And for this one, it's particularly important to pay attention to the title and what the labels are. Sometimes the labels are actually in the pie themselves, sometimes they're written towards the side. Here we have another type of chart, which is a divided bar graph. And this divided bar graph is much like a pie chart, but rather than putting it around in a circle, it spreads it out in a bar. And so the largest chunk is the largest group and so forth and so on. Now what makes bar charts and pie charts so good is you can immediately see proportion. You may not get the exact numbers like in this pie chart, but you can immediately see proportion. The largest bit takes up the most space and so forth, and so they're really great visual cues. But they lack a little bit of information. This pie chart has percentages. It actually, rather than having to measure the angle and figure it out yourself, it says, well, 29% of this circle is represented by the USA. USA is Australian students overseas. 29% of Australian students are in the USA, 16% in the UK, and 28% in New Zealand, and so forth and so on. These are really great for showing a big burst of information all at once and to just leaving you with a quick impression. Whereas if we look up here, line graphs and bar charts, they hold a little bit more information. You can compare a lot more things, and they're comparing two things here. Now, as I said before, it amazes me how many people would look at a chart and not actually know what the chart's about. And the main reason why they don't know what the chart is about is because they don't actually read the chart. They don't actually read the chart. And in particular, they don't read the units of the chart. So the first thing we do when we approach any chart, the first thing that we do is we read the title. I know that sounds like such a ridiculous thing to say, but it's amazing how many people don't do it. You read the title, so we know straight away this chart, even before we're asked any questions about it, is about internet song downloads. And then we look down here and we see months. So it goes from January, February, March, April, May, June, July. So it's coursing through the months, the first 7 months of the year. And what we see here on the vertical axis, on the y-axis, is the number of song downloads. And it goes up 50, 100, 150, and so forth. Once we know that, once we know these are the months of the year and these are the number of song downloads, we see that in January, boom, straight away, boom, we see that there are 300, and it pays to be accurate. It actually pays to pay attention. And I know this is a personal bugbear of mine. I often make silly mistakes, as you've probably noticed in videos. We move up. In between 300 and 350, there's a line between 300 and 350, there's 5 dashes. And so we see that the first line here, second, third, fourth, it's going up in tens. So we see that here, 10, 20, there's 320 downloads in January. Now, there's no question about that. That's just a logic thing that we see. And using a ruler and having a good graph, it can convey a lot of information. If I was to write this image of a graph, or this graph, should I say, if I were to write that as sentences, it would take ages and ages and ages. So, this example 1 focuses mainly on pulling out all the important bits of information. Question 1, what's the size of 1 unit on the vertical axis? So 1 unit on the vertical axis, we're going from line to line to line, the established was 10. I'm not going to write it in because I want my students to fill in this sheet during class time, and what I'm finding is they're just cheating and copying me. So I'm just going to talk about it, so you need to watch the video if you want the help. How many songs are downloaded in April? And so we look at April, I'm going to move it up. You see, it is exactly 50, 60, 70, 80, 280 downloads. In which month were 100 songs downloaded? So let's go to 100. Boom! July. And so after you've read the graph, after you've looked at what the units are and understood what it's actually saying, most of the questions that you get asked about interpreting graphs should be common sense. They should stand out to you. If they don't, then you either haven't interpreted the graph or there's some sort of implied maths in it. And for that, it's quite a large video, this one, I do apologise. For that, if we have a look down here, this pie chart refers to percentages of how many Australian students there are overseas. And if we look at question C, if a total of 3,685 students were surveyed, how many of them went to Canada? Although we don't know exactly how many went to Canada, we do know that it's 6% of whatever total it is. And so sometimes what students find difficult is pulling the mathematical sentence out of this. If 6% of 3,685 students were surveyed, how many of them is it? Well, it's just 6% times by 3,685. Okay.